Hello. In last lecture, we have discussed various aspects of different connections, which includes rivet connections, bolt connections, and of course, welded connections I have not discussed anything. And as rivet connections is becoming obsolete nowadays, so I have not concentrated on that much. I have concentrated the bolt connection in detail, and in case of bolt connection, when we are going to design, we need to know certain terminology that we have discussed. Today, I will discuss about the bolt connections in particular, where the different pattern of bolt connections we have discussed, and in different pattern of bolt connections, how the strength is going to vary, that will be discussed. Now, in case of bolt connections or in case of weld connections also, we have different type of arrangements, like depending upon arrangement of bolts and plate, we can design the bolt, we can find out the strength of the bolt. Again, depending upon the mode of load transmission, we have to design, and another thing is depending upon the nature and location of load. In nature and location of load also depends the design procedure. Now, coming to depending upon arrangement of bolts, we can see that we have two type of joint we can make. One is lap joint, another is butt joint. So, in case of lap joint, we have seen earlier also, we can make it single bolting, chain bolting and stagger bolting. And in case of butt joint, similarly we can have single bolting, chain bolting and stagger bolting. So, coming to the different bolting pattern, first let us come to the chain bolting. Let us see the chain bolting, how it looks. If we will consider, say, for lap joint, as we see earlier, in case of lap joint, the two plates are overlapped together and are joined by different way of connection like bolt, rivet or welding. So, this is called lap. Now, in case of chain bolting, the bolt will be in same line, in same row and column bolt will be. So, this is called, as I told, this is called gauge and this is called pitch, if force P is acting in this direction. So, this type of bolting is called chain bolting. Now, here you see the in case of chain bolting, I will discuss later in detail that it can fail in this way, tearing failure may happen in the plate in this way. So, in case of chain bolting it may happen. Now, in case of zigzag bolting, its position will be in a zigzag way. Say we have bolting here, then we have bolting here, maybe again we have here. So, the failure may occur in this direction, failure may occur in this direction. So, different way it may occur. That means, another way of occurring is this. So, we have to calculate what is the weakest section, and according to that we have to calculate the lowest strength of the connection, and then we have to find out the requirement. And in case this is called zigzag bolting. Another bolting we have, which is called diamond bolting. in this case the bolts are number of bolts are increased towards the center. Right. So, this is called diamond bolting. So, its failure may occur in this way by failing of this, like this different way it may fail, and generally we prefer diamond bolting because it is much more efficient. Now, as I told that depending upon the arrangement of bolts, we have, if we see that one is single bolted lap joint, this is only one bolt is there, right. So, if we see in the plan, we will see like this single bolted lap joint, maybe we have like this one line, right. Then triple bolted lap joint, double bolted lap joint also may have triple bolted, that means here we have triple bolted, in 3 columns it is. Then single bolted single cover bar joint, we know bar joint, that means 2 plates when are connected in same plane with an extra plate, this is called bar, and then this type of joint is called bar joint. Now, here we have cover plate of this thickness, we have cover plate, and we have one bolt here, another bolt here. That is why in each plate we have a single bolt, single row of bolt. That is why it is called single bolted single cover bar joint. And if we have 2 cover in top and bottom, then this is called single bolted, because one bolt in each plate, single bolted double cover bar joint, right. Similarly, here we can say double bolted double cover bar joint, because we have 2 covers and in each plate, this is one plate, this is another plate, in each plate 2 bolts are there, 2 line of bolts are there. That is why it is called double bolted double cover bar joint. Now, depending upon the mode of load transmission, we can define a single shear, double shear or multiple shear. So, the single shear when it comes, here you see when the 2 plates are joined together, this is one plate, another plate, and it is joined through bolt, then only one shear plane is there. That is why this is called single shear. And in this case, if we see that one shear plane is here where it may fail, another shear plane is here where it may fail. Therefore, this is called double shear. And you see, if the P is the force in this plate, then it will be divided by P by 2 and P by 2. And multiple shear means number of plates if it is joined by the bolt, and if number of shear planes is more than 2, then it is called multiple shear. So, here we see 1, 2, 3 shear planes, right, and from equilibrium equation we see this, in this direction it will be P by 2, and in this direction it will be P by 2, P by 2. Now, depending upon nature and location of load, we also can find out different type of connections like direct shear connection, eccentric connection, pure moment connection and moment shear connection. So, 4 type of connections we can see depending upon the nature and location of load. Let us see how it looks. Say for example, direct shear connection. In case of direct shear connection, we can see that if 2 plates are overlapped together, then this type of connection is called direct shear connection. So, when such type of condition will come, we will design the bolt accordingly. Due to shear it may fail, so we can find out the strength of the joint. Next is the eccentric connection. Eccentric connection means when a beam and column are connected together. Say for example, a column is connected with a beam member. And we have a member here. So, may be connected through gusset. If we have a load P here with an eccentricity E, and if it is connected through bolt, then such type of connection exerts moment, because this is an eccentric connection. So, for eccentric connection, here we will see the bolt will exert the direct load in this direction P by N. So, if N is the number of bolt, then and each bolt the force will come P by N, and also the moment will be P into E, moment will be P into E. So, because of this moment, the bending stress will develop, and because of that certain stress on the bolt will develop. In different directions it will develop, right. In this case it will develop like this, if it is center, sorry, in this case it will develop like this, in this case it will develop like this, perpendicular from the center like this. So, for this case it will be developing like this. So, this is how it will happen. This is called eccentric connections. Another case we have again, which is called pure moment connection. Pure moment connection. So, for this sometimes two members are connected with a pure moment. Say for example, like this, this is P and this is also P, means with E some symmetric loading is there. So, here only moment will be developed in the connection. So, this is called pure moment connection. Then moment shear connection. In case of moment shear connection, that is suppose say column, maybe I section, and we have a bracket, and this is connected in this way. So, it is connected in this phase, right. So, bolting will be in this way. So, in this case moment and shear will be developed. This is E, this is P. So, moment and shear will be developed. So, this is called moment shear connection. Now, we will discuss about the different type of failures, because when we are going to design a bolt, when we are going to find out the strength of a bolt or strength of the connection as a whole, we have to find out what are the type of failure may occur, and to arrest those failure, what are the mathematical equations are developed and how we will calculate the strength. So, if we see the failure of a bolt joint, we will see the failure may occur in this way. One is that shear failure of the bolt, then bearing failure of the bolt, another is tensile failure of the bolt. So, these three type of failure may come in case of bolt. Similarly, the plate also exert shear failure, bearing failure and tensile failure. So, we have to see the different failure and the least strength of a different failure will be the bolt strength. So, this is how we will calculate the bolt strength. Say first let us come to a failure which is called shear failure. So, this is a shear failure for different case with single shear and double shear. Now, if you see for single shear, that means only one shear plane is there. Between two plates only one shear plane is there. That is why it is called single shear failure. So, how the failure may occur, that the due to shear of the bolt at this point it may fail. Then in case of double shear, we have two shear plane. This is one shear plane, another shear plane is this. One is passing through the threaded portion, another is passing to the shank portion. So, here it may happen, means double shear failure may happen. So, when calculating the strength, shear strength of the bolt due to single shear or due to double shear, we have to know, means how the plates are connected, that we have to know. After knowing that, we have to find out whether it is going to be single shear or double shear. If single shear, its strength will be calculated accordingly. If double shear, its strength will be calculated in that way. Now, if we see some other failure, so we have shown shear failure in single shear and double shear. Now, we will see bearing on plate and bolt, bearing failure, how it happens. So, if we see the two plates, if it is connected and this is a bolt, then due to bearing on plate, it may fail. That means, it may fail like this. Is crushing. So, this is one type of failure which is called bearing on plate, bearing failure, plate and bolt. Another type of failure may come into picture also, which is called shear tear out of plane. That means, this is somehow it will look like this. This is crushing. Shear tear out of plate. So, such type of failure may also occur when force P is in this direction. another failure may come which is called tension failure of plate, because when two plates are under tension and we are going to join through bolt by insertion of hole, then along that whole line tension failure of plate may happen. Suppose we have bolt here. Now, what it happen? It may fail like this. In this way, the two plates may tear out in this way due to failure of plate. This is called tension failure. Tension failure of plate, right. So, this is another sort of failure. So, different modes of failure of bolt joints we are observing, and another failure is called block shear. Block shear failure. This may happen in this form, say a plate is connected with another plate, say for example gusset plate, and a force P is acting. Now, if bolts are like this, then this is a tension member, say this is a tension member and this is gusset plate. So, this block shear failure may happen in this way, say as a whole it may fail. This is one way, or sorry, this is one way, or we have this is another way. So, this is called block shear failure. Now, we have to remember certain things for a efficient connection using bolt, that is, one is the stress concentration results in a considerable decrement in the tensile strength. So, we have to try to avoid the stress concentration. Then loose fit of the joint can reduce the stiffness, which may result in excessive deflection. So, that has to be taken care. That means, we have to tighten the bolts properly, so that the loose fit does not occur and joint does not get reduced in strength. Then vibration cause loosening of nuts, which can jeopardize the safety of the structure. Due to vibration also it may occur. So, this has to be taken care, means we have to keep in mind while designing a joint using bolt. And certain criteria we have to remember for designing the joint under axially loaded members. First of all, the length of joint should be as small as possible to save material on cover plates and gusset plates. Say for example, we have a gusset plate connected with different type of members. Say for example, a truss member is connected like this. Now, it is meeting at a point. Okay. So, how do we join this? So, joining is possible. Say for example, we have a member here horizontal member, say angle section, we have another member, its CG is passing through this. So, we have to join in such way that CG of each members pass through a particular point, otherwise eccentricity may develop, then the moment due to eccentricity may come into picture. So, another member, say suppose is this, another member is joined through this. Right. So, while joining such type of structure, we have to see that the CG of all the members are meeting at a particular point, right, and the length of joint should be as less as possible to reduce the material, amount of material. That means, we have to join through, say suppose gusset plate to this structure. Now, if we have more number of bolts here, then we will not be able to reduce the length of joint. That means, we cannot reduce the amount of material required for gusset plate. That is why we have to keep in mind that as less as possible the length of joint should be. Another thing, as I was telling, the center line of all members meeting at a joint should coincide at one point only. That means, only one point it should coincide, otherwise the joint will twist out of position. The number of bolts should be increased gradually towards the joint for uniform stress distribution in bolt. I have shown one figure, if you remember, that for diamond bolting, we prefer diamond bolting, that number of bolts will be increased towards the center. Okay. Then the arrangement should satisfy the pitch, gauge and edge distance requirement. That means, the pitch distance, what will be the pitch distance, what will be the gauge distance, what is the edge distance, all the things has to be satisfied. Next is the strength of joint reduced due to the bolt holes. So, the reduction in area due to bolt holes can be minimized by arranging a zigzag form or diamond form. If we make, then arrangement can be made in such a way, so that the strength can be increased. So, in short, while designing a connection using bolt, we have to remember certain criteria. One is the length of the joint should be as less as possible, That is possible if we increase the diameter of bolt. We should not make use of large number of bolts. We have to try to reduce the number of bolts, so that the number of holes become less. So, the tensile strength of the member becomes high, as well as because of less number of bolt, the length of the joint will be less, and thereby the gusset plate required for joining plates will be less. So, the amount of gusset plate can be minimized through this. Another thing is, the members meeting at a point should be designed in such a way that CG of all the members are coinciding at a particular point. Otherwise, due to eccentricity, the additional moment may generate. That also has to be keep in mind. Another important things we have to keep in mind, that the whether we are satisfying the pitch and edge distance properly, pitch and edge and gauge distance, because as per codal provisions we have to consider the minimum pitch and maximum pitch. So, the pitch distance whatever we will provide, we have to be in between, that also you have to keep in mind. So, with this I would like to conclude today's lecture, saying once again that when we are going to design a bolt connections, we have to keep in mind what type of connections we are going to handle, and accordingly what type of load may come, and whether we are going for lap joint or bar joint, whether we are going for eccentric connections or concentric connection, we have to see, and accordingly we have to calculate the external forces, and then we have to find out the bolt strength. Once we get bolt strength, we can find out the number of bolts, and we can design accordingly with the use of codal provisions for pitch distance, edge distance and gauge distance. In next class, we will discuss the bolt strength due to different failure, means due to different aspects like bearing failure, shearing failure, tearing failure. What will be the bolt strength, that we will calculate as per the codal provisions. Thank you very much.